In this video, we are going to look at ratios in similar polygons. So our essential question that we're going to ask ourselves and know the answer to at the end is, how will I determine if polygons are similar and use those properties of similar polygons to solve problems? So first thing we want to look at is, what are similar polygons? Similar polygons, by definition, are part of our definition, they are polygons that have the same shape, but not necessarily the same size. Here's an example of a set of similar polygons. In this case, they are actually two triangles. You can see that they are both the same shape of the triangle, yet triangle ABC is larger than triangle DEF. So they have that same shape, but not the same size. Now, the other thing I want to point out here is the similarity symbol. The similarity symbol you see actually is the congruency symbol with the equal sign taken out of that. And the reason for that is because we have some congruency, but not all. So I want to come over here, want to continue with our definition of similar polygons. What we see when we look at our picture over here, we see that the corresponding angles are congruent to each other. And we see that the corresponding sides, they are not congruent, but in similarity, corresponding sides will be proportional. So we set it up just a little bit differently than when we were proving congruency. Alright, so if we go over here, we look at our angles that are congruent to each other by our tick marking: A congruent to D, B congruent to E, and C congruent to F. Now we're going to look at the corresponding sides. So if I see AB, I see that AB corresponds to DE. Notice there's no equals or congruency here. It is set up as a fraction, or we are going to call this a ratio. And then we go to our next set, so we would look at BC. You see that that corresponds to EF, again written as a ratio. And then our last two sides, that is side CA and FD. So now we're going to go back and we're going to look at the values that they gave us for these. So for AB and DE, we had lengths of 6 to 3, or simplified to 2. BC, side BC to side EF, the lengths were 9 to 4.5. Simplifying that, we also get 2. And CA to FD, we get 10 to 5, which also simplifies down to 2. So you see this number for all of our sides, corresponding sides, we see that when they are simplified down, we have the same value. We call this value our similarity ratio. Okay? That is the ratio of the lengths of the corresponding sides. In this case, that was all 2. So our similarity statement of triangle ABC similar to triangle DEF, we would say that the similarity ratio is 2. Now, if we reversed that order and we started off with our smaller triangle of DEF similar to ABC, what in actuality would do to that similarity ratio is it would actually flip it. We would have 3 over 6, 4.5 over 9, and 5 over 10. So our 2 would actually change itself, and the similarity ratio would be a half. So when you are working with similarity, make note of the order of your similar polygons, because that will make a difference in your similarity ratio. Let's just practice this a little bit. We're going to practice identifying our congruent angles and corresponding sides. So we're going to start over here with our two triangles here. We see that J and M correspond or are congruent. We see that L and P. So by our third angles theorem, what do we know about K and N? We know then that they, we'll put our 3 in, are congruent. So there's our corresponding angles. And then we look to the corresponding sides. So if I start off with JK, I come over here, J I know was corresponding to M, so that would be M to N. So that's our first one. And then if I go K to L, I know that that corresponds to N to P. And then our last one, our L to J, our L to J, L corresponding with P, that then means P to M, side PM. So there's our corresponding angles and corresponding sides. Again, your corresponding sides are written as the ratio. Now, I want you to stop the video and I want you to work this set of polygons here. Identify the congruent angles and corresponding sides. All right, how'd you do? Check your angles here, A to Q, B congruent to R, C congruent to S, and D congruent to T. Did you get it? If not, stop the video, go back, and double check. Now, how did you do on your corresponding sides? And also, did you write them as your ratios? AB corresponded to QR, BC corresponded to RS, CD corresponded to side ST, and DA corresponded to side TQ. Again, if you had difficulty with this, stop the video and go back and recheck your work. Next thing we're going to do is we're actually going to determine whether we have similarity with our polygons. And we're going to figure that out mainly by looking at our similarity ratio. If you'll recall back at our previous slide, remember those similarity ratios had to equal each other when we set up our corresponding sides. And then we will write, if they are, we will write our statement. Taking a look at our first set here, we have triangle EFG and triangle HJK. First of all, let's identify the angles. G we see corresponds to K. F we see corresponds to J. So by our third angles theorem, we then know that our E will correspond to our H. So we have congruent angles. Now we need to check the sides. So we're going to start off with EF. EF corresponds to HJ. So that gives us 10 to 15, or simplified down. Our next set, we're going to go with our FG of 12. That corresponds to the JK of 18. Or again, that simplifies down. We're almost there. Let's take a look at our last one. So then that means our EG and our HK, our EG of 17 to our HK of 25.5, simplifying down to 667. So we see that our similarity ratios are all congruent to each other. So we can say that these are similar. So we then have a statement. Triangle EFG is similar to triangle HJK. All right. I want you then to set this one up, and I want you to determine if the polygons are similar, and if they are, I want you to write the similarity statement. So pause the video. All right, how'd you do? We had since they were rectangles, all the angles were congruent to each other. They were all right, so you didn't have to worry too much about that. So setting up your length to your width, we had 5 to 15, and we had 8 to 24. They both simplified down to 33 hundredths, so you ended up with a similarity. And you could write your rectangles being similar, so you could just rewrite, and instead of and, you could put in your similarity statement. All right, the last thing we're going to look at is using those properties of similar polygons to solve our problem. So we again have two rectangles. We want to find what is the length of our second triangle here. So we're going to set up our ratio. So we're going to set up the lengths to our widths. We're going to write that proportion out. Then we're going to go back and we're going to put in those values. We're going to substitute those in. We're going to simplify that down. We're going to divide both sides by 27, giving us our answer of the length of rectangle HJKL. All right. I want you to go back and rewatch the video as you need to understand the values and bring this back to class.